Welcome. Hope you had a nice coffee break. I'm going to talk about a favorite topic of mine, productivity through quality. So the first thing to note is that it's not about productivity with quality. It's not about how can you be fast and still have quality. It's how is quality a requirement to be fast. It's how I think about it. This is a motivational speech. I'm hoping, like, if I do my job here, then you will all be fired up about building stuff with fantastic quality when you leave. We'll see if I succeed. All right, so a bit about me. Who am I to talk about quality? I have been doing software development for about 21 years. I have done it in a bunch of different countries. Not quite all over the world, but in many places. Many different companies. And I've had a lot of different roles when I've been doing this. So I would say, like, none of that necessarily qualifies me as an expert or somebody who's entitled to an opinion. But at least it means that I have seen software development done, like, in different ways, in different contexts, and you know, so. And I think also you know, I've been a coder for the last 6-7 years or so of my career. But I think my managerial background has made me think a lot about, like, how do we do things and why do we do them in different ways. So, to start with, why do we code? Any ideas? Why do we write code?
It's fun.
It's fun. Why do people pay us to write code? That's not because it's fun. The way I think about it, it's like this, you know. We're here and we want to get, so we're here. Where's my pointer? There, and we want to get to there. We want to have some sort of change, like, and how do we define here and there? Like, what is it? The way I think about that, you should define them in terms of some business impact. So, an example from the Spotify context. We measure something that we call the second week retention. And that's basically what percentage of users are still active with us 2 weeks after registering. So if it's like this in the beginning, then we want to change something so it becomes like the green curve. Right? We want to bump that up a few percentage points. That means our product is better. That means that people are happier with it, and they stay longer, and that we're going to make more money. So what code should you write to do that? Some if statements. Maybe a for loop. It's Java 8 now, so some lambdas, perhaps. You can't tell, right? There's no way you can say what code you should write. So how do you do this? I think you can think about it at like different levels. So you have the business impact on top, and to try to achieve a certain business impact, you can think about what features can do that for us. And you can guess, right? So, and then you can try to validate them and see, does this feature actually have the impact that I want? Okay? So in this example, we want to get from square to star. Let's try building a pentagon feature. That didn't work. Let's try a triangle. That was better, but not quite right. So let's shift it around a little bit. And then, you know, we add a diamond, and great, we're good. We're where we want it to be. And these features are built on code or using code. So what does the code look like to do these things? It's something like this, right? You know, you start out some way, and then you realize, okay, the pentagon was a bad idea. Let's delete that and go through another path. And your code takes a really crooked path, right, to get you to where you want to be. And the way I think of this is like this. So it's like we're, you know, Bilbo and the dwarves walking on the floor of the Mirkwood, and we don't really know where we're going, so we have to climb a tree sometimes and take a look at and see where we're still going. And the danger here is that you get so involved in what you're doing down there on the forest floor, like fighting spiders and avoiding black rivers and whatever else they do there, that you lose track and you forget that you should actually be heading towards the lonely mountain over there. So like the whole validation concept, I think that's very often missed. right? You build features because some product owner told you to do that, and that product owner thought the feature was good, but maybe doesn't know. So like that feedback loop is sometimes not there. Okay, so given that we think that this is what the evolution of our code looks like, it takes a path that looks something like this. What does that tell us about our code? What requirements does that place on our software development process? How do we need to work? Well, we need to be able to delete code. We need to be able to modify code, tweak the behavior. It tells us that longer iterations between these two blue dots is riskier, because it means that we run a bigger risk of running in the wrong direction and wasting lots of time and and energy on building the wrong thing. If we spend a lot of time building something as well, that means we invest more in it emotionally, so it becomes harder for us to abandon it. A thing that we built, we tend to love it, and we don't want it to be destroyed or deleted because it was bad. So, we want to have short iterations. We want to be able to turn quickly. So, like, we shouldn't have like a slow-moving super tanker that moves in one direction and cannot turn. We have to be able to be a bit agile and shift around. And how important is that first result? It's probably not very important. Right? Where we get to in the first step, it's mostly just a stepping stone. It's somewhere we want to go to see, is this a good direction to keep moving in or not? The important thing is, where do we end up in the end? And if we know that that's going to take us several iterations of trying things and discarding them or tweaking them, that means something for how we should think about our software development process. To me, it does. Okay. So how do we code? I'm not going to ask you for an answer to this. It's a difficult one. But here's some data on how we code. This is time spent in front of a computer actually coding. It's not meetings, it's not emails, it's not anything like that. And this is from a survey or work done by a guy called Peter Hallam, who used to work at Microsoft and develop Visual Studio. And he found that, on average, programmers spend 2 to 5% of their time building new code or writing new code, 20 to 25% modifying existing code, and 70 to 80% trying to understand existing code. The reason why numbers are like that is that new code gets old very, very quickly. And you need to add new code to existing code, and therefore you need to understand and stuff. So Peter Hallam's conclusion was, as one of the guys building Visual Studio, was if we can make Visual Studio so clever, like even give it psychic abilities, so that it can understand what people would like to write and make that free, that would give a 5% productivity improvement at best. But if we can instead work on features that help readability and help people understand the code they're looking at, even if we just make that 10% easier, it's a bigger productivity improvement. And, but we don't build Visual Studio. We do have some sort of impact on our development processes and how we do things, how we build things. And the way I like to think about these numbers, like in my context, is that if we optimize for writing code quickly, you get a very, very small productivity bonus. That's the 2 to 5%. That's the biggest number you can change here. But if you optimize your development process for readability and understandability, that's when you can get like a big impact and really improve your own productivity and that of your colleagues. So we should optimize first for readability, like in the output of what we write, and second for malleability or changeability. Writing new code, it's not such a big deal. We can take a bit more time doing that. Okay, so that was like background, some to set things. Now I'm going to talk about quality, which is like the meat of this presentation. 2 years ago, I wrote a blog post where I said that developer-facing quality is a completely different thing from end-user-facing quality, and it's usually more important. And what I meant by that was basically this: that there are, at least 2 kinds of quality. There's probably more. But if you think about product quality, that's the thing that users of a product experience. So, is it easy to use? Does it not crash when I try to use it? Is it attractive? Is it simple? All these things are product quality. And implementation quality is the thing that people working with a product, monitoring it, operating it, deploying it, building it, coding it, that's what they see, or we see. So it's things like, ease of understanding, do we have great regression tests, do the builds work, and those things. And, when I started working in '95, I was fresh out of university and sort of knew something about the theory of computer science, but not very much about the practice. I remember a course I was given where the teacher said, you should build something with the right quality. It should always have the right quality. And the right quality is not perfect. Because obviously, the law of diminishing returns applies, and the last few bugs are going to be harder to find and harder to fix than the first ones you find. So initially, it's easy to find and fix bugs and improve the quality, and as you go along, it's going to be harder and harder. So you should not aim for perfect quality. And that's true for specifically. It's very true for product quality, because product quality is the thing that will sell your product, right? And therefore, it's a thing that will sell your product, not the only thing. Features will also sell your product. So when you are deciding whether to fix a bug that causes your program to crash, you can instead decide to add another feature or improve a feature, and that'll make the product more attractive. But implementation quality, it's a meta feature. It determines how quickly you will be able to fix bugs and add features in the future. So keeping the bar low on implementation quality, or not, or like prioritizing features over implementation quality, is going to slow you down. Everybody clear on that distinction? Does it make sense? Yes? No, so that is nodding heads. That's great. So I wrote this blog post 2 years ago. I was pretty proud of it. I had these concepts, and I thought they were a bit original. I hadn't heard of them before. And some people, colleagues of mine, reviewed it and said, "Yeah, this is great stuff. I like it." And on my desk, I have 4 books that I go back to and refer to occasionally. One of them is called "Growing Object-Oriented Software Guided by Tests." I highly recommend it if you haven't read it. In that book, they define 2 concepts that they call internal and external quality. It's a book I read about 6 years ago, or 7 years, 5 years ago, whatever, first time. And the exact same idea. So I thought I'd invented something. No way. You don't have new thoughts. I think my names are maybe slightly better, because I think product quality says more than external quality about what it is. And implementation quality is maybe a bit better than internal. So that's why I kept them here. But it's manifestly not my idea. I stole it unconsciously from Stephen Freeman and Nat Price. Right. Another person who had the same idea, I would say, or at least thoughts in the same area, is Martin Fowler. He has what he calls the design stamina hypothesis, which he's been talking about for a very long time. And basically, what he's saying is, if you don't pay attention to design, which to me is a subset of implementation quality, so the same reasoning applies, then you follow this blue curve here. So you have time on this axis, and you have cumulative functionality, total number of features added on this axis. So on the blue line, initially you'll add features quickly, then at one point the lack of design, lack of implementation quality is going to slow you down, because it'll be hard to fit something else in there because it wasn't flexible, that thing. And then when you change this thing, then that thing over here breaks, and you have to spend lots of time on regression testing and so on. And eventually you find yourself here, which is in some kind of a black hole where it's incredibly hard to move anywhere, and any change is risky, and you prefer not to do them. And it means that you change the way that you think about your whole product strategy, because you cannot change this system because it's legacy. Anybody been there? Yes, everybody almost, I think. The orange line is different. It's where you pay attention to design from the beginning. It means you go a bit more slowly initially. But if you look carefully, you can see it actually slopes upwards a little bit. So you're actually accelerating the rate at which you can add features over time. And the reason for that, like the logical reason for that, is that you're actually creating building blocks here. Things, you know, that will help you solve problems in your particular domain. So you will have great tools for deploying stuff here, or for solving this kind of problem, or for abstracting that kind of thing that you need to do. Anybody been there? Up here? Yeah? Some people have? It's great. I have. It's fantastic. It's much nicer than here. Try to go there. Also, an observation that he makes is that if you have, like, the total number of functionality that you need to implement in your product is less than this line, then you can choose the blue option. Just hack it up, don't worry about stuff. You'll get it out faster, and it's a good thing. If the total amount of functionality that you think you're going to add over the lifetime of the product is above that line, then you should not trade off implementation quality for time to market, because it's going to slow you down. You know, once you pass that line, then when you're here, what can you do? If you continue to not pay attention to quality or design, you're just going to slow yourself down even more. And going from here to there is an extremely painful and costly thing. And in general, people don't do it. We did something like that at Spotify with a client we have, and it was like a process of, depending on when you think it's done, it's probably not done yet, but you know, at least a year and a half with almost 0 features added, just refactoring, being completely at a standstill as a startup. It's a very painful thing, you know, to experience. So, and usually I think when you are in like somewhere on the blue line, then you stay there, or you do a rewrite eventually, and that rewrite fails. So you try again 2 years later, and that might succeed, or that fails again. So, okay, enough about that. So, for me, like the basic step in order to get to great quality is tests, developer-written automated tests. So I'm going to talk a bit about that. But first, imagine, picture some code, some perfect code, a shining diamond of production code without tests. Everybody has some production code in their minds? Yep. Does that even exist, like perfect production code without tests? I wouldn't ask the question if I didn't think no. And I'm going to try to make that argument a bit more concrete, like why can there not be perfect production code without tests? Let's start with some code. Java code. Everybody can read that, I hope? Yes, some people in the back are nodding, good. So it's a class called multiplier. It has a single method. It's called multiply by 0.25. It takes an amount and returns the amount times 0.25. So it's very simple, like, and it's obviously perfect. It's going to return the input times 0.25 every time. Perfect code, no tests, but we don't need them because it's so simple. So here's some other code. It's a value-added tax calculator. Has a single method called calculate VAT, which takes in an amount and returns the amount times the VAT rate, which is 0.25. And this code is broken, right? Because it's, I mean, for one thing, it's using floating point to do arithmetics. And we know that, you know, floating point and money, it's a bad combination, right? So it is, for sure, it's unsafe. And also, if you think about it, it's like, okay, so we're in Sweden right now, and the most common VAT rate is 25%. But not if you're buying books or food, then it's a different rate. So it could have some bugs there, but we don't know, do we? And if you're, obviously, if you're like trying to use this when you're in Poland, then it's going to break. And I know in Poland they have sometimes they have 2 different VAT rates that you need to calculate separately and account separately, because there's a luxury tax that you have to use. And another thing about this that is a bit fishy perhaps is that, you know, in Sweden we generally see the price, the total price including tax, and then if we want to calculate the VAT, it's actually 0.20 that we want to use, not 0.25. So is this before tax or after tax? We don't know. So, but it's the same code, right? Is it? What's different? What happened here? When we changed the names down here, this code became more specific. It gained context, right? This is just math, has no context. This has a lot of implicit business rules that we sort of understand that they are there somewhere. We don't know which ones apply. But we see that there are rules there. There's hidden assumptions and context in there that we don't know where you know, that means that we call the code into doubt. On a bytecode level, it's the same thing, but because the name's changed, we see that it's different. So how does that relate to tests? Well, you know, if you do tests right, then the tests will be a requirement specification for your code, and they can help explain what are the circumstances when it should be used, how should it be used, how should it work, and all these things. So here's a famous quote that sometimes makes it up really high on like lists of the top 100 quotes in software. And it's there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that there are no obvious deficiencies. The first method is far more difficult. It's a quote from Tony Hoare, the inventor of quicksort, as well as the null reference, which he calls his billion-dollar mistake. He's sure that it's cost the software industry more than $1 billion, and so he regrets that. I think he came up with it in like 65 or something. So why do I have this here? It's because it's my opinion that simple is not enough. If you think about the code on the previous page, it's extremely simple. It doesn't, you know, you don't have to be a skilled programmer to understand what it does, I think. But simple is not enough, because your production code can only tell you what it does, right? It cannot tell you what it should do or why it does what it does. And that's where, you know, great tests can help you. They can tell you like some of the rationale, and you can have more information in the tests, and they can show somebody who wants to make changes why the code works as it does. Another quote, this time from Brian Getz, the language architect for Java. It's from JFocus a few weeks ago, where I would actually encourage you to click on that link later on. He's putting words into Yoda's mouth and does a pretty credible Yoda imitation. I'm not going to try that. And he says, there is no good, there is only good for. So, meaning that, you know, code cannot be good in isolation. It has to be good for something. There's no intrinsic value to code. So the perfect production code diamond, it's not good in itself. It's good if it's good for something. And if this is what we think the evolution of code looks like, it's a crooked path, and sometimes you take false turns and you have to back up. Then again, this diamond without the test becomes a less useful thing for this kind of life, where it has to change, because every change is risky, and great tests will provide you with like regression test feedback that will help you guide your code through this path and take it that way. And in particular, like this continuous modification is happening in a business context with a lot of hidden or implicit assumptions that are too complex to actually specify or to get right using names. I mean, you could the code, the VAT calculator could say, it could be not calculate VAT, but calculate VAT for non-food, non-book items in Sweden before, and then the amount could be like amount before tax. And then it would be clear, okay, now we know what it does. But you don't write code like that, and you don't even think like that, because it's too specific. Okay. I'm done with the code, but I haven't had the time to write tests. How many have said that? I've seen a few have, yeah. Some proudly, some not so proudly. I don't know if I have, but I think I probably have at one point or another. So, like, I'm going to explore a little bit if that's a true statement or a feasible statement to make. And in a way, it is, because when you write tests, like the impact of writing tests is, there are some speed up factors, some things that are going to make you faster, and some things that take time for you and that are a cost. So, like, you'll be writing about twice as much code if you write tests in a good way. I think that's a fair number. Like, I don't know exactly what it is, but it's between 0.8 and 1.5 times as much code, I think. And you will have incidental test breakage. So remember the code path, like it changes a lot. When you want to change something because you actually want to change the feature, then some tests are going to break. How many? Hopefully as few as possible. Depends on how you do things, but it's definitely a cost. On the bonus side, you get simpler code. I'm going to talk a little bit more about what I mean by that and how that happens. You get shorter feedback cycles. The obvious one there is the regression errors or reporting regressions. Like if you incidentally break something here when you change something there and you didn't want to, then finding out from an automated test that runs the minute you make your change is great. Finding out 2 months later when some customer runs into that problem is not great. So shorter feedback cycles there is like key to productivity. But it's actually more than that. I have when you have like a complex system that involves more than one thing, sometimes you have really difficult state that you need to keep track of. And so I have a favorite example from my own experience when I was working on building games. I was working on a card game, which had like a multiplayer card game. So there was a server with business logic and 2 clients with user interface and some business logic. And and I ran into a bug. I was testing it locally on my machine. I ran into a bug, a UI bug in the client. And this thing is like it happened because with a random draw of like 60 cards or whatever, and then I played 3 or 4 turns and making different moves on each of the clients. How am I going to reproduce this situation? It's really hard. But luckily, I was running these things in JRubble actually. And I could see the stack trace from the client UI with a bug. And I could reproduce that stack trace with a unit test. OK, yeah, seems like it's the same bug. Recompile, reload, and I could see the UI working. So instead of having to try to fix something blindly, and then try to regenerate the same draw of the cards and try to make the same moves and see, have I fixed the bug or not? I could actually find out within a matter of seconds after having done it. So that was me being a little bit lucky, but I think it's true in general. Like if you have complex systems and you can reproduce your bugs with a unit test, then your feedback cycle is much shorter, and it makes you more productive even in the short term. So most of the things I'm talking about are productivity improvements, medium to long term. That one is a short term one. Design improvements. So in order to make code testable, it has to adhere to some good design practices. You have to have loose coupling, you have to have high cohesion and these things. And in particular, if you do TDD, test-driven design, so you write tests before you write code, then that helps you drive your design to a better place. Okay. And I've been getting questions about this picture. Why should the scales be even? Like, no, they should tip over. So you want the speed up factors to be heavier than the slow down factors. But the thing is, depending on how you do it, you can get there. So the slow down factors can actually be bigger than the speed up factors. In particular, which one is bigger, do you think? Writing twice as much code or incidental test breakage? Second one? Yeah, by far, I think. In particular, if you think about Peter Hallam's conclusion that we spend about 2 to 5% of our time writing new code. So this is 2 times, roughly, 2 to 5%. It's not that much. But this one can be huge. You can spend hours on trying to find some weird bug that happened, or having to update like 100 test cases because you've made a change here. So how you write your tests is crucial to, and the thing you want to do when you're writing your test, is to minimize incidental test breakage. Okay, let's talk a bit about how tests make your code simpler, because I didn't spend much time on that. And I think for me the main thing is that if you write your tests first before you do implementation, it forces you to think about what before you think about how. And that means you have to understand the problem before you come up with a solution. And if you understand the problem better, then you're going to solve it more simply, you know. And we tend to, I think it's a human tendency anyway. It's definitely a tendency of mine and of many of the people I've been working with to like jump into solutions very, very quickly. And when we do, then we're on the forest floor again. And like we don't see exactly where we're going. So we just, you know, hack around here and hack around there, and suddenly, eventually maybe we get something working, but it's likely to be a lot bigger and more complex than it would have been if we had thought more about the problem, thought more about the what before we started getting into the how. Yeah. And sort of similarly, like in order to keep your tests, to stay away from incidental test breakage, so tests breaking when they shouldn't have, you're making a valid change here. Obviously, you need to test the things, to change the tests that test the thing you're changing. But you don't want to have to change these tests because they have nothing to do with that. And a great way of getting to a state where you don't have a lot of incidental test breakage is by testing what, not how. So testing how means, for instance, typically like when you're testing a lot of hows, then you can see a lot of mocks and spies and argument captors and that sort of thing in your test code. That means you're testing implementation. You're verifying that when I call this method on my test object, then it calls this method on the other object with these parameters. And you're really closely tied to the implementation of something that's, you know, on the other side of the object you're testing. And that's the sort of thing that tends to be very, very hard, to tie you into specific implementation. You want your tests to test behavior, not implementation. I'm not going to talk too much about that, but feel free to take a look at that growing object-oriented software book when you have time. And the other thing that you have to do is I would say you have to do that. I had to do that anyway, is adapt the production coding behavior. You shouldn't write your production code the same way as you used to do if you happen to have, you know, been on the blue line and producing this kind of legacy code. You need to write your production code in such a way that it becomes testable. It's an actual objective of your production code that it's testable. Because your production code has to be good for continuous modification. So therefore, it's actually a requirement on your production code. And therefore, it should be one of the things you think about, even when you're actually writing the code. Okay. So here are some things that can destroy productivity or make you less productive. I mentioned the quote or the instructions I was given as a noob. Don't build the perfect quality. So, like unnecessary quality, it's something that can slow you down. Spend too much time on fixing bugs and making things do good. Another thing that can slow you down is unvalidated features. So you're building features that are actually not necessary. And the third thing that can slow you down is poor implementation quality. You're on the blue line and not the orange line. And I think it's interesting to talk about these things a little bit separately. This one, unvalidated features. There is a pretty famous report or infamous report from 2002 by a group called the Standish Group, where they surveyed, I think, 20 or 30 or something different software systems. And they found that 64% of the features in those systems were rarely or never used. 64%. So that means, and about 20% were often used. So that means that we could become 5 times more productive by building the right things. And so this is obviously huge. I think we all see that in our daily work as well. We're building stuff that isn't being used. It's the wrong things. And this I have seen a lot of in, I think, at every place I've been. So not paying attention to design and implementation quality. But I've never been a place where that's been an actual problem. I was told, don't build perfect quality, and I didn't. Maybe I don't know, maybe I should have. Maybe not. I mean, it really does make sense that the law of diminishing returns applies, and you shouldn't try to fix every single bug. But I do think in practice, this is something that sounds a lot more scary than it actually is. This one, doesn't sound scary somehow, but it's a really big culprit in terms of waste. Research shows that. So to combat that, I think thinking in these terms is a good idea. Where's my pointer there? So actually, define your features in terms of business impact, usually or often. Like it's here. You don't think about the impact, you think about what you should do, not why. And make sure that, so validate your features and discard them if they turn out to not produce value. Because a feature that sits in your code is not free, it's going to slow you down in the future. Another interesting thing when you're contrasting these two, unnecessary quality and unvalidated features, is over-engineering. What is over-engineering? Is it too much quality? I build a framework where I should have built just a one-off thing that connects to a database. Is that too much quality? No, it's not. It's engineers inventing features where they're not needed. Pluggability is a feature. Like building a framework where I could have just built a one-off thing quickly that would have got the job done is a feature that wasn't needed. So, and generally speaking, we tend to have like frameworks and processes and stuff in place to keep product owners in check. So at Spotify, we have a mantra that we call think it, build it, ship it, tweak it. So, do something quickly, validate the feature quickly against, production users and real traffic, and then see, is it good enough? Well, maybe we should discard it, or maybe we should tweak it and make it better. But we don't have that for engineers. So I, as an engineer, can invent any feature I want, and nobody's going to sort of question me, because the POs don't understand what I'm doing. But if I am a good engineer, then I think about these things, and I realize, okay, I actually shouldn't make, it possible to do whatever. I should not over-engineer things, basically. I had another one, and this one obviously is about, do you get onto the blue line or the orange line? And my recommendation is the orange line, if that wasn't obvious. So why is this so hard? This is actually, I think, the 4th iteration of this talk that I'm doing, and one of the questions I got early on, a year ago or something, was why is it so hard? Oh, everything you say makes perfect sense, but why is it so hard? Why don't people do this in practice? Why don't I do it in practice? And I didn't have a good answer. I think I have an okay answer now, maybe. I don't know. You guys will have to be the judges. I think it's primarily 2 things. It's awareness and skills. So skills, because it's actually hard to do things like test drive your code. So writing tests before you're writing production code is actually hard. It's a different way to think about things, and it makes you more uncomfortable because you're staying in problem space. You're trying to figure out what you should build without looking at the how, and it's hard. It's the what is harder than the how in some ways. I'm not saying you should figure out all of the what before the how. Sometimes you need to go back and forth a little bit. Like, so what? Then can I do that even? Okay, another what? Can I do that? Yes, I can do that. So, but it's hard. And it's also really, really hard, at least for me, to write good tests. So tests that don't cause lots of incidental breakage. It's hard to structure the production code such that it won't be, leading to things breaking in the wrong places or action at a distance. But I think almost more importantly is the awareness bit. And part of it is, I think, people don't think about quality in terms of implementation versus product quality. It's almost only product quality. That's the only thing that most people think about. And there it does make sense to trade off features for quality. I don't think it makes sense in the implementation quality side of things. So that's something I hope you guys will remember. And then there's also other things, like the slow feedback. When you're here, like when last time you were working on a system like this, were you also there at that point? Did you write the legacy code, or is it somebody else's code that you're maintaining? Chances are it's somebody else's code. This time period might be years. So it's really hard to be like aware of this. The feedback cycle is extremely slow. You build something, and then 2 years later, you realize that, okay, this was actually poorly built, and it's impossible to maintain and change. Chances are, the people who wrote it aren't there even. And also, it's like this analogy with a boiling frog. Like you put a frog into hot water, it jumps out. If you put a frog into cold water and turn up the temperature, it doesn't notice that it gets too hot and dies. I don't think it's true, but it's an analogy. And it's the same thing here. The being on the blue line is a very slippery slope, and slowly you make small changes that weren't quite the right things, and then you add a little bit of complexity there and confusion here, and then suddenly you are in a place where you have like a really hard time modifying the product that you're building. It's usually not the case that you make like one change, then it's completely broken. It adds up. It's really hard to detect. And then there's the visibility. So like an example from the physical world, imagine you're going to put up some shelves on a wall at home. So the thing you need is shelves and screws and a screwdriver. Right? No. Because you need to figure out what kind of wall is it. And you maybe need to drill holes. Maybe you need to get other kinds of screws or plugs, or like expander plugs if it's plaster walls. And once you've done that, and you've measured things so that they're like straight and stuff, you drill holes, you put them up, then you still need to vacuum so you get rid of the dust. But when you're doing that, when you're working in the physical world, it's really obvious that there's dust lying on the floor. Like, you will go and clean it up. But you don't see it at all in the same way in code, in your systems. It's much more hidden, so the visibility isn't there. All right. So wrapping up, optimize first for readability of your code. Design your software process such that you create readable code, because that's what you and your colleagues are going to be doing for the most of your time later on. Optimize second for malleability, for the ability to change the code without breaking everything else. And don't worry about writing new code. It's not a big deal. It feels like a big deal, but it's not really. The benefit from tests depend on the test quality. So make sure that you're really good at writing great tests. I didn't talk about how to do that, but just do it. Separate implementation quality and product quality in your minds and in your discussions with product owners and other people. Implementation quality is more important. Don't let go of that, because it's going to slow you down in the near future. Don't add unvalidated features. Kind of obviously for the POs, but don't do it yourself either. And train yourself to be really alert on the alert for water temperature changes. And that's it. Any questions? Okay, and thank you so much.